Hi everyone, welcome to RS Academy. This is Sunil. In this video, we are going to discuss regarding non-deterministic finite automata. Finite automata are of two types, deterministic and non-deterministic. In this class, we are discussing regarding non-deterministic finite automata. Non-deterministic finite automata which allows multi-transition for one specific input symbol. So look here, the finite automata are called non-deterministic finite automata where there exist many paths for specific input from the current state to next state. Look here, Q0 is the present state where for B it has a multi-transition. It had a Q0, it moves to Q0 and here it moves to Q1. So one specific input of B had a multi-transition which termed as a non-deterministic finite automata. Okay, in non-deterministic finite automata, there will be allowing of a null moves. It means that no need of all input symbols transition in a particular state. It may or may not be contain all input symbols transition in a particular state. Whereas in deterministic finite automata, there should be existence of all transitions for a particular input in every state. Okay. So look here, Q0, Q1, Q2 are the three states. This is a transition diagram of non-deterministic finite automata. So we'll try to describe with the help of tuples which are Q, sigma, Q0, F and delta. Okay. So first Q, finite set of state. So note it down, the finite set of states from here, Q0, Q1 and Q2. First note that Q0, Q1 and Q2. So this is the finite set of states. Next, finite set of input symbols. Look here, what are the input symbols which are there? A and B. Only two input symbols. So take it down. A and B, two input symbols. And coming to initial state, there is only one initial state. In every transition diagram, it's Q0. This symbol indicates that it's an initial state. Coming to final state, it may or may not contain one final state. In some diagrams, it may contain multi-final states. Here, only one final state. Okay, Q2. Initial state, in general, it will be only one initial state. Final state, it may contain one or more than one. Okay, and transition function of non-deterministic finite automata can be represented as delta. So Q, any of one state, if you provide the input symbol, so it may give 2 to the power of Q transitions. Okay, it means that if any of a state from the Q, if we provide symbol from any of symbol from sigma, then it gives 2 to the power of Q form, Q transitions. Why? Because you can see that here Q0, it had with B to Q0 and with B to Q1 also. Okay, transition will be like Q0 state, if we are reading about this Q0, and by giving A, it moves to Q1. It changes to Q1. In the similar way, we can show that delta Q0 with B, it moves to Q1. Q0 with B, it moves to Q0. Okay. So coming to transition table, present states. How many states are there? Three states: Q0, Q1 and Q2. So Q0, Q1, Q2. At Q0, by giving A, we'll get Q1. Okay. And at Q0, by giving B, we'll get Q0 and Q1. Q0 and Q1. Coming to Q1 state. At Q1 state, by giving A as input, we'll get Q0. By giving A0 as, and coming to here, after A, by giving B as input, it gets to final state Q2. Coming to final state at Q2, by giving A, we'll get Q1 and we'll get Q2 both. So Q1 and Q2. and Q2 by giving input B will get Q1. Okay, here. So we can see here for B will get both Q0 and Q1, and here for A will get both Q1 and Q2 state. So this is regarding non-deterministic finite automata, which accepts for specific input multi-transitions and it allows null modes. Okay. Thank you for watching. Do share and subscribe our channel.